K8BYP at breakfast with a copy of Radio Magazine. Mobile operators put up a wire beam, I think it is, and one CWR had one. From January 1940. Disclaimer, we didn't tell you to build the antenna. If you build it and kill yourself, it's your problem. To go to page 33, UHF and the weather, a really neat article about what causes UHF propagation. And heads up, it's the same thing that's causing propagation now with no sunspot activity. I've been tracking this for years, for going on 7 years now. And repeatedly, consistently, there's no propagation. Like a couple days ago, 40 was absolutely dead. Hardly even any local. But no propagation unless there are weather disturbances. Well, that doesn't agree with the ionospheric, sunspot, tropospheric, layer D, all that stuff. And there's a reason for it. There's an explanation. That's including, I'm getting routinely 6,000 miles of DX. Not a great deal further. The topic here is the mechanics of refraction of UHF waves in the lower atmosphere. And that's what it is, and that's what it is now on HF. For comparison, instead of this book, which is difficult to find, get a copy or go online and find the book on atmospheric propagation by John Seybold, Seybold, PhD, not hobbyist, who says a similar thing. Electromagnetic waves are bent farther from normal. Normal refers to them either going, and never coming back, or going in a more or less, we assume, a straight line until they impinge on the curvature of the Earth at some distance. That's called the radio horizon. Then, particularly EHF, they can't go through the Earth, they can't go around it. There is such a thing as improperly termed hilltopping or refraction at the ground. I saw it happen in Illinois on 6 meter. I was at a rest area down below the elevation of the peak of the road, a couple miles ahead, and the signal refracted into, it was a town near Peoria. But anyway, in case of UHF bending, the medium, of course, is air. And the question arises as to just how air alone could cause our signals to be refracted. Notice the topic. Mechanics of refraction. How this could cause our signals to be refracted. What is refraction? Refraction is the change in a vector direction of something propagating through a medium which can propagate that something, and then have it change angular direction. Refraction is not reflection. The laws of physics for reflecting electromagnetic energy are radically different. And notice this is a source, or back in the days where this myth of atmosphere reflecting radio waves and causing some mythical NVIS comes from. What does bend our signals is a useful amount of this. What does bend our signals a useful amount is a stratification of different types of air masses. Seybold says the same thing. When a relatively warm, moist air mass touches a cooler mass, the resulting, and this is vertically oriented, not horizontally. One air mass over the other or under the other touches a cooler mass. The resulting meeting, okay, here's the myth and the gross mistake. The resulting meeting plane acts to UHF waves different as different media, and the waves are bent. Okay, notice bent. Probably by the same mechanics as light refraction, so he doesn't know. But knows the myth of a plane. Now suddenly he's jumped topic and invoked a myth. So realize this is amateur. And this was 1940. So what do we want? Planes do not bend and refract energy. They reflect. And according to the science I've read on the topic, and this is critical, when electromagnetic energy impinges normal on a surface, depending on the wavelength, it is spread out across a surface, not reflected according to the myth of NVIS, which is something somebody has made up because it does not appear in credible scientific literature. Something hams have made up. Bending. Bending is not sharp and sudden necessarily. It's a grazing. And the word oblique is important. That's what's used in regard to this refraction. In the case of UHF bending, okay, now back to the correct topic, bending, not reflection. The gradient is tipped upside down in order that the bending be downward and thus of use to us, and consequently the phenomenon might be visualized as an inverted radio mirage. It is much like the case of seeing the setting sun due to refraction, to get back to the correct topic, after it is actually beyond the horizon. And that's what our radio receivers are seeing on the receiving end from a transmit station that's below the radio horizon. And we shouldn't be able to hear that transmitter. That has to do with my location here being way down in a hole. I'm at 820 feet mean sea level. I'm looking up at the top of a stack that's 1,000 foot high. And if I go to West Knoxville, I'm looking down on that stack. I'm in a serious hole in the ground, probably 1,500 feet. And when this propagation changes, I can hear signals that are going overhead. And I've correlated that with somebody talking with them on the air. The signals are going over me. They're not being bent down in. Ross Hull, HULL, showed that signal strength over a long indirect path follows the existing lapse rate anywhere in the region of 300 to 2,500 meters altitude. Seybold talks about an atmospheric layer extending up to 3,000 kilometers above the Earth's surface. This figure is right inside that one. So this is limited to the extreme low portion of the troposphere. So UHF bending takes place in the lower troposphere. So does HF. It's all going through the same air. The article goes on to talk about clear day and the puffy clouds, a good deal of heat on the Earth's surface, cooling in the evening. Under such conditions, increases moisture content. Sun sets, Earth cools faster than the air. Cools the air in direct contact with it, results in low altitude inversion. And that sounds a great deal like what we call the gray line. The timing is the same. When both air mass stratification and substance are present, usually at two distinct levels, tremendous bending takes place, and often the low altitude stations exceed in signal strength at a distance of 200 to 400 miles the more fortunately located stations. Seybold talks about that also, that this extending the radio horizon is also accompanied by extremely strong signals. And this is the other half of the NVIS myth, that the signals must be strong because they're going up and coming back down. Well, that's a 120 mile path up and down and chance for scattering. And the NVIS myth is that there's a reflecting surface up there. There are no surfaces. There's nothing up there to reflect from. There's no sunspot activity. And that would spread the energy out. It would not result in a very, very extremely strong signal. And certainly if it were going up and reflecting, we'd hear our own signals, and the NVIS myth believers never hear their own signals. And an interesting blurb about the rotation of the Earth in the atmosphere, causing slippage and formation of cyclones. As far as a hurricane goes, 4 or 5 years ago, the big hurricane came over Houston. There was a long arm of that storm that came directly over me, basically touched the East Coast. Then on 40 meters, the VK stations were generally gone by 8:30 or so local time EST. There was a VK being received at 20 over in New York and Florida at 10 o'clock in the morning. I was hearing him S9 and a bit plus, which is extremely unusual. And that's more than radio horizon extension. So watch for the weather. Notice when the weather map is clear, I look on AccuWeather.com. Ain't gonna be much propagation. Unfortunately, we have to wait for the storms and the lightning noise and the chance of being hit by lightning to get propagation. So that's the way it is when there's no sunspots. So 1940, the day of the new 1623 transmit tube. Check that out. Here's real radio. Get the living crap knocked out of you touching that in the wrong place. KBYP did it.